Hi guys, welcome to Nat 4 and we're going to look at adding and subtracting decimals today, and we're going to look at different methods and different strategies to use. So let's look at the first question. So we've got 2.6, add 0.7. So let's look like a concrete method or pictorially. It's kind of pictorially in this, but if we were to do it in class, we would actually use concrete material. So if we were to take 2 units, that would be your 2 units. And how would I represent 6/10? I would take 6 of these. 1, 2, 3, 4, 4, 5, 6. So that represents 2.6 because you have this one here which represents a unit, and this one here which represents a unit, so that represents 2 units, and then each of these represent tenths, so that represents 6/10. So that represents 2.6. Right, if I was to add on another, there we go, if I was to add on my 0.7, there is no units to add on, there is just 7/10 to add on. So again, I'm going to add 7 of these tenths. So 1, 2, 3, 4, 5, 6, 7. Okay. Now, if I was to put all these beside each other, I should know from the previous video that 10 tenths, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tenths is the exact same as 1 whole. So I could delete all these or exchange all these even. Go up here, give these back if you like, and exchange it for a whole. Okay, I'll just delete them now. It's a little bit clearer. So now we've got 1, 2, 3 units, so 3 whole numbers, and we've got 3 tenths. So how would I write that? And it would be 3.3 is my answer. Okay, I'm going to do some other methods as well. I'm going to look at partitioning next. So I'm going to split up a 2.6 into 2 and 0.6. I'm going to split up 0.7 into no units, 7/10, so we split that into 0.7, and then I'm going to add. So first of all, I'm going to look at the wholes, the 2 and the 0 added together, which is obviously 2. And then I'm going to add the 0.6 and the 0.7 together. So 6 add 7 would be 13, so it would be 13 tenths if you like, but 13 tenths, 10 of those tenths would represent a whole, so this would equal 1.3, and then if you were to add 2 and 1.3 together, you get 3.3. Again, same answer as before. What if I use a number line? So if I'm just going to try and get a straight line up here. Yep. So if I was to use a number line, okay, I can start at 2.6 and I would add on 0.7. Now you can do this in many different ways. If you're not comfortable with adding on 0.7 straight away, you could literally go up in 0.1s if you wish. If I did that, you would have to do 7 jumps. 1, 2, 3, 4, 5, 6, 7. And if I added on 0.1 every time, okay, add on 0.1 every time. You can do bigger jumps. That's the beauty of a number line. You can do whatever you're comfortable with. So if I go up in 0.1s, it becomes 0.7, then 0.8, 0.9. And it really becomes 2 wholes in 10 tenths, but you know that becomes 3. Then add in another 0.1, 3.1, 3.2, and 3.3. There we go, 3.3 again. All right. This one I'm talking about one number partitioned mental strategy. So you're really thinking about this 2.6, and you could do this with the number line as well. And you're thinking about splitting up your 0.7 so that part of it can be added to the 2.6 to make a friendlier number. So because of your knowledge from the previous video, you should know that I could split up 0.7 into 0.4 and a 0.3. Now I've chose to do that because my 0.6 and my 0.4 will add together to give a nice friendly whole number. 2.6 add 0.4 is going to give me 3. And then I've got another 0.3 to add on, which gives me 3.3. So again, same answer. Compensation. So if you rounded a number there, again, this could be a good one to do mentally. If you were to round a number, I would probably say let's round this 0.7. What is a friendly number that 0.7 is near? And it would be 1 or 1 whole. So if I change this calculation to 2.6, add 1, but knowing in my head that I have really added on 0.3 to that 0.7 to get my whole, then 2.6 add 1 whole is 3.6. But you added on an extra 0.3, so you need to compensate there by taking that away again or subtracting that. So we need to then subtract the 0.3 away from the 3.6. And again, that would give you an answer of 3.3. And then there's a formal method, or the column method, or the up-down, upstairs, downstairs method. I've heard many different words used to describe it. So you're just placing one on top of the other. You're making sure that your decimal point lines up with each other. And you're going to add each column. So let's look at the tenths first. You're going to do 6 plus your 7, which is 13. We should know before from previous videos and from what we're doing here. So 13 really means 10 tenths, which means a whole. So that's why I'm carrying a whole over here. I'm going to line up my decimal point, and then I'm going to do 2, add my 1, add my 0, which is 3. So again, you get an answer of 3.3. Okay, we're going to try that again with a subtract calculation. So here we go. Very similar setup. So 4.6 subtract 1.8. So again, if we start with the concrete or the pictorial method, so I'm going to start with 1, 2, 3, 4, and then so that's 4 units or 4 whole numbers, and then 6 tenths. So 1, 2, 3, 4, 5, 6, and I want to subtract or take away 1.8. Now it's quite easy at the moment to take 1 whole away from. Now I'm just going to make sure that I'm just putting a line here. So we're looking at the ones below the line, not above the line. It's easy to take 1 whole away because you can see that there's 1 whole there, but there is not 8 tenths. I only have 1, 2, 3, 4, 5, 6 tenths. So what I'm going to have to do is I'm going to have to exchange. So I'm going to have to take one of these wholes, so one of these units. I'm going to put this back into the bank over here, and I'm going to ask for 10 tenths in exchange. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now again, I'm just looking below this line from illustration here. So you're now going to take away 1.8. So can you take away 8 tenths now? So let's look 1, 2, 3, 4, 5, 6, 7, 8. So I've highlighted 8 tenths. Now you're subtracting that or taking that away. So I could basically just take that off by deleting it. And that's my 8 tenths away. So there's this part here. And then I need to take a whole away as well. 1 whole unit. So I'm going to delete that whole unit there. So what are you left with? I'm left with 1 unit, 2 units, so 2 units, and 1, 2, 3, 4, 5, 6, 7, 8 tenths. So 2.8 is your answer. Okay. We're going to look at partitioning for this one as well, and number line and computation and formal methods. So I'm just going to rub this out, sorry. Partitioning, again, is a wee bit trickier, I think, with subtracting. So you've got your 4 plus your 0.6, and you're taking away 1 plus your 0.8. Again here, if I do this part 0.6 take away 0.8, I can't do that. So I'm going to have to go and exchange it and borrow another 10 tenths or another whole over here. This is very similar to almost the formal method. So then I've got 1.6 take away 0.8, which is 0.8. Then I've got 3 here, subtract 1, which is 2, and 2 plus 0.8 is 2.8. I actually don't really like that method, the partition method for subtracting. I think it makes life a wee bit trickier. If I look at the number line method, there we go. Now, this is my favourite method when subtracting numbers. It turns a subtracting calculation into an adding calculation. So you start with the number that you are subtracting and you count on, hence the name. So counting on method, that's what it's called. Counting on method. You're going to start with the 1.8 at the beginning of your number line, and you're going to count on until you get to your target of 4.6. So again, you're going to talk about friendly numbers, so you're going to make a little jump. What would be the next friendly number after 1.8? A nice whole number, a nice friendly number would be 2. So what do you add to 1.8 to get to 2? You add on 0.2. Now our target, remember, is 4.6. So I'm going to make another jump to 4. What did I do to this 2 to get to this 4? I added on another 2. And then my last jump, remember my target's 4.6. I'm going to jump to 4.6. What do I have to add to 4 to get to 4.6? And it's 0.6. And then all you're doing then is adding these jumps together. So you'd add your 2, and your 0.6, and your 0.2 together. Again, you can lay that out in a formal way if you wanted, or you could just add in your head. So again, the answer, if I was to lay it out, I just want to show you something. Sorry, I've lost my pen. Where are you? If I was to lay it out, 2, 0.2, and 0.6. Now I could write it like that there. You have to be very careful that you line up your decimal points. Now, a number that you can't see a decimal point has a decimal point sitting after it. And if you want to put a little placeholder in here of 0 to make life a little bit easier, so every number in this calculation has the same amount of digits, then you can do that. 2 and 2.0 are the exact same. And then when you add them together, start at the the right hand side, 0 add 2 adds 6 is 8, put your decimal point in, and 2 add 0 is 2. So again, 2.8. Compensation, again, you could use this as a mental strategy. So if you started at 4.6, instead of subtracting 1.8, if I rounded that to a friendly number, if I rounded that to 2, my answer would be 2.6. But I have rounded that number up. I have added 0.2 to that number to get to 2. So then I have to let me just repeat that. So I have added 0.2 to this number here. So I have taken away 0.2 too much. So I need to add on another 0.2 to get my final answer of 2.8. And there's a formal method, 4.6, subtract 1.8. I'm going to borrow or exchange here. So 6 take away 8 you can't do, so you're going to borrow or exchange. Oops, so I'll just put that out. You're going to borrow from this 4 here, goes down to 3, you're borrowing 1 unit, it becomes 10 tenths. Okay, so this is now 16 tenths if you like, so 16 take away 8, which is 8. Put your decimal point in, and 4 take away 1, which is 2, which is the answer that we have got in every question. We'll do one more example for you. Okay, and we've got 6 subtract 1.08. Again, you could do the concrete method here. I think the number line is the best method for this question. I just think, especially a question when you've got a whole number take away a decimal, I think the number line is by far the best option. Let me just show you the number line one first. Okay, so again, we're going to start with a number we are taking away. So we're going to start with 1.08, and I'm trying to get to my target of 6 at the end of my number line. So I'm going to add on to a friendly number. So you might want to add on, first of all, to get to 1.10 or 1.1. I've just wrote 1.10 to make it a wee bit easier for you just now. So you would have to add on 0.02 to 1.08 to get to 1.10 or 1.1. Once you get to that, you might be able to do a bigger leap then to a really friendly number, a whole number of 2. Now, what would you add to 1.1 or 1.10 to get to 2? You would add on 1.9. You have to think about that as 1.90 for the moment. That is also fine. So when I add them on, I get to 2, and remember my target is 6. So I'm going to go from 2 to my target of 6. What do I add to 2 to get to 6? And I add 4 on. And then you're going to add all of them together to get your final answer. Again, you could put them underneath each other, but they're all in different columns, so this is actually quite easy. There's no carrying over, so your answer is 4.92. And I really like the number line method here. Thinking about this as well, these types of questions often come up when they're related to money. It's perhaps you've started off with a £5 note and you go out and you buy something that costs £2.36. How much have you got left over? So I think the number line is a really, really nice way of doing it. Compensation or mental strategy over here, I would say, is another nice way for doing this one. So if you want to think about it as, say I said to you £6, take away £1. So I'm just going to round this 1.08 just now just to one whole. Your answer is 5, but you still have 0.08 to take away. If you think about that in terms of pence, sometimes that makes life easier for kids. So if you've got £5 and you take 8 pence away, what would you have left? I'm going to write this in terms of pounds. So you would have £4 and 92 pence left. Okay. I'm not going to go into the formal method and partition and concrete method or pictorial method for this one because I think they two are the best options. Thanks very much for watching. Thank you. Bye now.